This morning, I'm joined by Charles Jones from the Safety Office. We're going to be talking a little bit about electrical safety. Good morning, Charlie.
Good morning, Jennifer.
Now, what everyday items do we encounter that might cause some electrical hazards for us?
Today I'm going to focus more on home electrical safety. We'll follow it up with a short video that's more relevant to workplace electrical safety. Some of the items that you're going to run into in the home that are potential electrical hazards include your everyday wall outlet, multi-plug adapters, cords, and electrical panels.
Okay. Now, we're all pretty familiar, I think, with the standard wall outlets that we have, but what can make those a hazard?
Well, you always want to make sure that electrical outlet is equipped with a faceplate, that the faceplate is not missing. Make sure it's not cracked or broken like this one. The outlet itself, make sure it's in good condition, that it's not cracked or damaged in any way, because on the back of the outlet you're going to run into exposed wires and exposed fittings.
Okay.
Another thing, if you have small children in the home, I recommend putting these in the outlets that are not being used so that the child can't come along and stick something in there and get shocked.
It's a good idea. I know I used those when my son was really small. Now, you also mentioned some multi-plug adapters. Now,
Have one of these. I understand why people need to use these from time to time, but the problem with these is, as you can see, there are 6 outlets here that you're actually being serviced by one outlet, and you can inadvertently overload the circuit by using this piece of equipment, and for that reason I don't recommend using these, because you can actually start a fire if the circuit gets overloaded.
okay, so you want to watch basically how much you plug into any single outlet, and doing this you can easily overload the amount of energy that it's supposed to be sending
Yeah, the
out.
typical wall outlet is rated for 15 or 20 amps.
Now, around water, we typically see some non-standard outlets, the kind with the little buttons on them. Now, tell us about those.
Okay, that's a ground fault circuit interrupter. And it's designed to be used in wet locations such as bathrooms, kitchens, laundry rooms, places like that, outdoors. And the way this operates is that if you have an item plugged into this, and say it's a hair dryer, and it goes to ground, this circuit, this item will actually shut the power off to the appliance. Another a hazard with this is if you have, we'll use the hair dryer again. If you inadvertently drop that in the sink full of water, it's going to keep everything safe. These need to be tested according to manufacturer's instructions. They recommend testing these on a monthly basis.
Okay, so if we haven't tested all of our outlets that are in our watery areas, we probably should do those.
Yes.
At least once a month. Now, you mentioned some cords and power strips earlier. Now, what should we be looking for whenever we're using cords?
Okay. I brought one with me and I've made some modifications to it. One of the things I find quite often is when you have a cord that has 3 prongs on it, and as you can see, this one is missing the 3rd prong. It's a grounding prong. You don't want to use a cord without the grounding prong on it. Another thing, you don't want to use a cord where the sheathing is pulled away from the plug. And then, of course, you don't want to use a cord that is damaged in any way.
Now, if we do remove the grounding plug, what are we risking?
You're risking a shock hazard.
Okay. And the same for the insulation around the wire as well?
Absolutely.
Okay. Now, are there any additional tips that you want to ensure that our employees get?
Yeah, I'd like to touch on electrical panels. The modern day electrical panels are going to be equipped with breakers. These are similar to a switch, and what you'll run into in some older homes will be fuse panels, and they will include an item like this. This is a fuse. The main issue with these is if one of these trips, people often put in a larger rated fuse. For example, this one is a 20 amp fuse, and if it trips, somebody will likely put in a 30 amp fuse because they figure, well, 20 amp wasn't large enough, so I'll put in a 30 amp. The problem with that is circuits are based on the size of the wire. So you don't want to ever put a larger fuse on a circuit designed for a certain amperage.
So don't use just whatever fuse you've got laying around. Make sure it matches whatever was in there before.
Exactly.